On the moon, the real estate market is skyrocketing. While I'm being a little tongue-in-cheek when I say that, it is true that interest in the moon as a permanent base for human life is increasing. Before December 2022, the number of countries and political unions that had successfully sent probes either to orbit or land on the moon has risen to 6. America, Russia, Japan, Europe, China, and India have all sent spacecraft to our closest lunar neighbor. The motives behind this vary even within country. For some, it is about scientific advancement. For others, the moon offers rich possibilities for economic gain. But whatever the motivations, knowing where to set up those first lunar bases is becoming increasingly important. And that means mapping out the moon's surface and features is more vital than ever. Fortunately for everyone involved, the Lunar Reconnaissance Orbiter has been circling the moon from an altitude as low as 50 kilometers from the moon's surface since 2009. Its mission has been to map out the moon's surface in detail and to enable scientific discoveries that help us understand the processes that take place up there. We have spoken about what it has seen before, but we've only scratched the tip of the iceberg when it comes to the moon's haunting beauty and deep mystery. What has the LRO found up there? How does it pertain to mankind's reaching for the worlds outside our atmosphere? And how may its next generation take that search even further? I'm Alex McColgan and you're watching Astrum, and today in my 6th video on the LRO, you're about to discover the answers to those questions. As a quick recap, the LRO was launched by NASA in 2009 as a means of mapping out the lunar surface in hitherto unmatched detail. But when this was achieved after just 1 year, NASA shifted LRO's mission to investigate areas of particular scientific interest. We've spoken in my last video of the highest and lowest points on the moon, as well as relays, and some truly impressive impact craters. But that is not the thing of greatest value to future explorers. In fact, one of the most important features on the moon is a humble hole in the ground. This is a pit crater. By evaluating the shadow, scientists can discern that it's a massive 100 meters deep and 100 to 115 meters across, depending on where you measure it around its sheer edge. Unlike impact craters, which are formed from space debris crashing down onto the moon's surface, it is thought that pit craters like this one are formed by a cavity collapsing deep underground, similar to the process that forms sinkholes here on Earth. This provides further proof that under the surface of the moon, there may exist networks of caves and vents, possibly formed by flowing lava long ago. The moon is cold now, so these lava tubes lie empty. But this provides astronauts and scientists with a unique opportunity. If they do exist, it's incredibly likely that lava tubes will provide a remarkable, easily accessible record of the geological processes that shape the moon. They might be coated in interesting and rare minerals. On top of that, it's much easier to set up a base on the moon if your walls and ceiling are already formed for you. Lacking a magnetic field or any real atmosphere, the surface of the moon is completely exposed to solar and cosmic radiation. Over time, this radiation could deliver a lethal dose to any would-be settlers. The only way to avoid this would be to line your buildings with thick materials to block out the radiation. But 100 meters of rock will do the same job just fine. If pit craters provide a gateway to cave systems 100 meters deep, astronauts may well pick out a site much like this one to settle on the lunar surface. Of course, any would-be settler will not just need protection from radiation to survive on the moon. They will also need access to water, and it's here that LRO has provided some more fascinating insights into the moon's surface processes. It was once thought that the surface of the moon was dead and dry. If water existed, it would only be found in small pockets in permanently shadowed regions. However, as LRO traveled over the lunar surface, it began to notice something unexpected. trace amounts of water molecules could be found over the top of the surface regolith, the grey rock that makes up much of the moon. It turns out the moon is ever so slightly wet. This wetness was even observed to move around in a sort of lunar water cycle, both by region and by time of day. Around noon, when the moon's surface was hottest, the water seemed to dissipate, but then would return with the evening. Scientists do not understand everything about this process. Where did this water come from? Why did it not all evaporate into space? But LRO's observation means that the locations on the moon that might be viable for a lunar base is suddenly much wider. If this trace amount of water could be collected, you would not need to build your base next to a permanently shadowed region, which is convenient because PSRs are far colder than we at first thought. The moon has very little axial tilt, a little over a single degree. This means that at the poles there exist craters that are never pointed directly at the sun. No matter what time of day or year, the sun never casts light into their mysterious basins. Naturally, a location that never sees any sunlight is bound to be cold. However, scientists were not prepared for exactly how cold it turned out these regions were. For context, at the equator, temperatures on the moon fluctuate between 120 degrees Celsius during the day and minus 130 degrees Celsius during the night. LRO houses a diviner instrument, which uses 7 thermal infrared channels to measure surface temperatures. With it, LRO found a polar crater that had temperatures as low as minus 250 degrees Celsius, making it the coldest temperature measured on any object in the entire solar system. That's colder than the average temperatures of Uranus, Neptune, or even Pluto. The crater edges shielding these areas from solar radiation might have created the perfect storage location for housing water ice, but other more interesting, useful compounds could be found there too. Carbon dioxide, carbon monoxide, dinitrogen, and argon perhaps. These compounds could be useful for settlers, and so accessing these materials might be extremely useful in spite of the chilling cold. But because it's so dark down in these craters, it's difficult to know for sure exactly which craters house what. It would be unfortunate to build a scientific base, only to discover that the crater next to you was completely empty. Sadly, LRO's onboard camera, the LROC, is not capable of piercing this darkness. But there is a new camera circling the moon that can. The reason why I said in the intro that 6 countries had sent probes to the moon before December 2022 is that on the 16th of December, that number actually rose to 7. After a 4.5-month journey, South Korea's Danuri probe just arrived in lunar orbit. NASA has actually been working closely with South Korea on Danuri, providing them with scientific expertise and communications and navigation support in a spirit of mutual international scientific collaboration. In thanks, South Korea's KARI space program gave NASA 7 kilograms of space on their Korea Pathfinder Lunar Orbiter, or Danuri as it's locally known. A composite word made from dal, which means moon, and nurida, which means enjoy. NASA considered what scientific instrument could be best placed on Danuri, and in the end they went with a device known as ShadowCam, a younger sibling of LRO's own narrow-angle camera, with one notable enhancement. Thanks to its 200 times sensitivity, it turns images like this into images like this. This incredibly clear image is of Shackleton Crater, found at the moon's south pole, the first ever site photographed by LRO. And now, thanks to Danuri and ShadowCam, we can properly peer into its inner basin. It turns out that Shackleton does not look that different from many of the other craters on the moon. Its cratered floor is covered in bumpy hummocks. Sadly, there is no obvious ice here. Perhaps this is because Shackleton is a smaller crater, meaning that the temperatures within do not drop quite so low as would be needed for ice to reliably form. One point of interest is the clear trail left by a boulder as it rolled down the crater side, visible near the top of the image. Such tracks are common on the Moon, as the lack of wind means that any disturbance of the dusty ground is never covered up again. This track could be extremely old. This is the only image released by ShadowCam so far. However, Danuri intends to orbit the Moon for the next year at least. In that time, it will hopefully drive back the shadows on all of the Moon's hidden terrain. So, there you have it. Thanks to the LRO, and now Danuri, the surface of the Moon is being mapped in clearer and clearer detail. Processes such as the lunar water cycle are being understood more deeply, and the way is being paved for future missions to actually land on the Moon through the discovery of compounds vital to human life. And that's not even mentioning the developing scientific understanding of the origins and history of the Moon that is coming about as we uncover its geological record. When scientists one day arrive on the Moon to study this record firsthand, it will be thanks to this data that they will know where to go. As the number of nations settling on the Moon increases, they will rely more and more on LRO and Danuri's information to know where to construct. That's what excites me most about all this. We are, metaphorically, brick by brick, laying the foundation for possible future civilizations. Thanks to the knowledge being developed by these orbiters and pathfinders, one day, millions of humans might just call the Moon by another name. Home. Humanity has always loved new frontiers. In the 16th century, when Christopher Columbus first sailed to America, thousands of Europeans embarked on a perilous 6-month voyage across dangerous oceans to follow him. When they arrived, they knew that there would be none of the trappings of European civilization waiting for them. They would have to farm, build shelters, and work hard just to survive. Many didn't make it, either dying in the crossing or in the years after arrival. But it didn't stop more from coming. It couldn't. The call of the new frontier was too strong. Fast forward to the 21st century, and before us lies a new frontier: space. Despite its beauty, it is the most hostile environment imaginable. Space will burn you to death. It will freeze you. Its radiation will kill you. The changing gravity will crush you or waste you away. Not even breathable air can be taken for granted. Yet, this frontier is calling to us. Perhaps it highlights something within human nature that we would strive to go to such a desolate place. Maybe we relish the challenge. There is something that speaks to certain souls about going somewhere hostile and deadly and building something warm and safe there. Or maybe it's curiosity. There is so much to learn about the universe around us. And while looking at photographs and measuring conditions through instruments is interesting, there is nothing quite like experiencing a place, a phenomenon, a wonder of the universe firsthand. Plus, being physically present opens up whole new avenues of science. And so, humanity's sights are set on the other planets in the solar system. Mars might have humans walking on it as early as 2033. But it begins with the Moon. The Artemis mission intends to get humans back to the Moon by 2024. Through doing so, it will develop new technology and explore technical frontiers currently uncharted. The technical expertise gained from this enterprise will enable scientists to create spaceships capable of carrying human life to the wider solar system. It begins with the Moon and with Orion 1. I'm Alex McColgan and you're watching Astrum. Join with me today after the recent successful splashdown of the first crewable spacecraft to travel to the Moon and back in nearly 50 years. This mission will open the doorway to distant planets. So what did it do over the course of its nearly 26-day journey? The answer to that gains us a fascinating insight into how close we are to having a human on the Moon once more. Orion 1's journey to the Moon and back started at Launch Complex 39B at the Kennedy Space Center in Florida. The atmosphere there was tense but excited. This was an important mission. It had been nearly 50 years since the conclusion of the last space race. But just like that previous one, America is not the only one trying to get to the moon's surface. The Chinese National Space Administration landed a rover on the far side of the moon in 2019, and they have recently developed a rocket, the Long March 9, that could potentially carry a human to the moon in the 2030s. NASA is nothing if not competitive. They hope to be the first ones back up there. For that to happen, Orion 1's mission would need to go well. The journey was planned to be a complex retrograde orbit, meaning traveling in the opposite direction to the moon's orbit of the Earth, swinging around the moon 3 times, 2 of them close flybys. But this was no mere attempt at threading the celestial needle. More than flying accurately, Orion 1 would be testing out the various onboard systems needed to support human life on such a journey. Many pieces had to be working perfectly. A single failure could be fatal for anyone on board. Of course, Orion 1 was not carrying human passengers for this trip. That would be for the later Artemis 2 mission. That said, there were passengers of a different sort. Introducing Commander Munikin Campos. Munikin Campos is a mannequin dummy filled with radiation sensors designed to record the levels of cosmic exposure astronauts might experience inside Orion 1's crew module. The name is a reference to Arturo Campos, an electrical engineer who helped save the Apollo 13 mission by designing a fix after its oxygen tank ignited. Which is a nice nod. I do love the name Munikin though. Munikin was accompanied by 2 other mannequins built for a similar purpose, but for different body types and genders. As female astronauts are going to be heading into space as part of later Artemis missions, it's important to see how space travel affects them specifically. The clothes these mannequins wear, and Orion itself, will need to protect the mannequins from cosmic radiation. Most agencies say 50 millisieverts is the maximum safe amount of radiation a person can be exposed to in a year. On the moon, levels can get as high as 380 millisieverts. If NASA cannot get these exposure levels down to more manageable levels, it will pose serious health risks for any future astronauts. Orion 1 launched. This was the maiden voyage for both it and the rocket carrying it. The Super Heavy Lift Space Launch Vehicle rocket is NASA's tallest and most powerful rocket to date, and currently the most powerful in the world, providing 3.8 million kilograms of thrust at launch and capable of lifting nearly 70,000 kilograms and sending it on its way to the moon. Useful for carrying Orion 1, along with 10 CUBE satellites that NASA would be using to monitor space conditions for future missions. Although it was initially delayed, Orion finally fired up through and out of the atmosphere before detaching from its other stages and beginning its journey. And as a personal side note, I have never seen a rocket launch like this one. The power you can see through the video is simply incredible. I've seen a lot of rocket launches in my time, but this one was jaw-dropping. The first phase of the flight had begun. It would take 4 days to get to the moon, but NASA had no intention of wasting the time. Immediately, on the very first day of space travel, they started to test. And surprisingly, this meant it was time to activate Alexa. Yes, that Alexa. Alexa made it on board as part of a collaboration with companies Amazon, Cisco, and Lockheed Martin, as part of Orion 1's Callisto payload. This payload is a suite of video conferencing and voice command technology paid for by the companies, as an attempt to prove how useful such software could be as part of NASA's initiatives. Technicians on Earth were able to call Orion 1 and speak to Alexa, getting her to access information on telemetry and flight status. It's an intriguing use of the technology being showcased. One day, just like in sci-fi, perhaps all of spaceship control will be voice activated. On the 3rd day of Orion 1's journey, once some course adjustments had been made and it was well on its way towards the moon, Orion 1 performed a visual examination of itself. There was always the risk of micrometeors hitting Orion 1's surface, and taking these photos would allow NASA to confirm the extent of the damages caused by this potential cosmic threat. It was a reminder of one of the potential dangers Orion 1 would face. Fortunately, while results are still being analysed, it seems that micrometeor impact damage was minimal on this trip. In those first days of travel, Orion 1 took images of the planet Earth, shrinking the further from it the spacecraft travelled. It also started looking ahead. This first lunar flyby was an important one. Orion 1 would be travelling over sites visited by its predecessors, such as Tranquility Base, where Apollo 11 landed, or the sites of Apollo 12 and Apollo 14. Travelling close to the lunar surface would be a good dry run, excellent practice for any future missions where they need to drop off cargo or personnel. However, it also demonstrated one of the most important, repeatedly tested aspects of Orion 1's flight, its autonomy. For 15 minutes, the moon's mass would block out communication with Earth. NASA is deeply concerned with astronaut safety. As such, they have worked hard on developing backup systems into Orion 1 for what would happen if ever Orion 1 lost contact with Earth and had to navigate on its own. You can't just access Google Maps when you're traveling 8,210 kilometers an hour, over 370,000 kilometers from Earth. Although they did test GPS connectivity while they were on this mission, just in case. Like sailors traveling across the seas in ancient times, Orion 1 would need a compass to help it find its way. Its method for doing this was actually very like those sailors. Orion 1 can navigate by using the stars. The spacecraft comes equipped with an optical navigation camera designed to be able to use the position of the stars to track its position, orientation, and motion in space at any time by comparing what it sees with onboard digital star maps. At numerous points on this journey, scientists tested systems related to making sure this capability worked and wouldn't be jeopardized by anything space had to throw at it, such as the warping effects of solar heat. Fortunately, these systems all worked perfectly. Orion 1 was able to maintain a sense of its position and kept going in the correct direction. After passing through this zone of radio silence, Orion 1 was able to pass back around the other side of the moon and easily re-establish contact. And while doing so, it was able to record an incredible sight, an inverse to what we see here on Earth, an Earthrise. Then it was time for more tests, including one of my favourites, the sloshing test. Fluid mechanics are complicated. Being able to predict how liquids like engine fuel will move under acceleration requires advanced computer models even on Earth. But once you add to that the complexity of variable gravity levels, it almost becomes easier simply to go up to space and see. NASA was keenly interested in how much and in what ways the fuel on board Orion 1 would move under thrust, otherwise known as sloshing. This would provide valuable data that could be used to predict how much Orion 1's thrusters might be needed to perform various space maneuvers. Over the course of the next 2 weeks, Orion 1 performed its delicate lunar orbits. During these complicated maneuvers, Orion 1's thrusters were tested intensely. It takes mathematical precision to dance along the line between crashing into the surface of the moon and flying off into space. Without thrusters that performed exactly as needed when needed, Orion 1 would not have enough fuel to complete its trip, even with the extra supplies it carried. As it happened, Orion 1 performed more efficiently than expected. Its thruster burns were exactly what NASA had hoped. It was able to do its second lunar flyby, passing as close as 130 kilometers from the moon's surface. While many things went well, there were difficulties too. On day 8, for reasons that remain unclear, Orion 1 dropped out of communications with Earth for 47 minutes. On top of that, on day 19, power temporarily dropped out to the ship's heaters and propulsion subsystems. Fortunately, NASA were able to get these systems up and running again. The second stage of its journey was complete. The final stage, re-entry, was all that remained. Could Orion survive re-entering Earth's atmosphere? To make the process easier, Orion would only attempt to get its crew module home. This detached itself from the rest of Orion and dropped towards the planet. To ease its way into the atmosphere, Orion's crew module performed a skipping maneuver, similar to the way you might skim rocks across a body of water. This dip and bounce technique slowed its speed, allowing it to try to land at its desired location with greater precision. Still, temperatures got so hot during re-entry that the friction turned the air around Orion 1 into plasma. Orion 1 dropped out of radio contact temporarily. NASA had expected this, but they still had to wait with bated breath as Orion's autonomous systems worked to stabilize its entry and as its new heat-resistant exterior plating tried to protect its residents within. At 2,900 meters above sea level, traveling at over 200 kilometers per hour, Orion's parachutes began to deploy. First, 3 smaller ones to remove the bay doors. Next, 2 drogue parachutes intended to begin slowing Orion's arrival. And a minute later, the main parachute. Together, these parachutes slowed Orion 1's entry to the point where a human on board could survive it. On the 11th of December, Orion 1 splashed down in the Pacific Ocean. Activating a wide array of signal beacons, it called for someone to pick it up. It was the USS Portland that came to collect it. Scientists waited for a couple of hours while the outer casing cooled. This also allowed them to perform even more tests. This time, the tests were on how the salt water of the sea affected various Orion 1 systems, and evaluation on how it had done at resisting the heat of re-entry. Analysis of that is still underway, but the initial results look positive. The passengers within were not cooked by the 2,800 degrees Celsius re-entry temperatures. We are also waiting on NASA for data from the radiation sensors on the mannequins themselves. But they had done it. They had run their race. The data the Artemis 1 mission had generated would be instrumental in allowing NASA astronauts to stand on the surfaces of worlds other than our own again. Humanity's quest to reach ever further frontiers continues. For Orion 1, its part in this ever-developing journey was complete.
The race to get back to the moon is on. Or is it? For more than 50 years, the footprints left by the 12 Apollo mission astronauts have remained undisturbed on the moon's surface, perfectly preserved as a symbolic trophy of Cold War rivalry. Through NASA's Artemis missions, the plan was to get back there by 2024, and this time, not just leave footprints, but to stay. Since then, things have slipped a bit. But Artemis 1, an uncrewed mission to put the SLS rocket and Orion capsule to the test, eventually launched on the 16th of November 2022. Its follow-up, Artemis 2, was scheduled for launch in February this year. But guess what? It's still stuck on the ground. On the launch pad, in fact. No lunar footprints in sight. So what is going on with NASA's Artemis? Will Phase 2 be taking off anytime soon? Or are there larger problems that are finally coming to the surface? I'm Alex McColgan, and you're watching Astrum. Join me today as we propel ourselves into the inner workings of the Artemis program, from the technical glitches currently grounding Artemis 2 to the unexpected announcement that Artemis 3 will no longer land on the moon. We're going to delve into the science and strategy of our return to the lunar frontier. Will we ever get there? Artemis is arguably the most complex engineering endeavor in human history, aiming to establish a permanent, sustainable presence on another world. Yet as we stand on the threshold of this new era, it seems like the path to get there is becoming increasingly difficult. First announced in 2017, this was to be the flagship NASA program for the next decade, in many ways attempting to revive and perhaps even outdo the feats achieved by Apollo in the 60s. They made it to boots on the moon in just 8 years before, and with all the technical advances we've had since then, surely the second time round should be easy. It would seem not. 9 years after the initial announcements, and we are nowhere near. The immediate priority for NASA is Artemis 2, the first mission to carry humans back to the vicinity of the moon since 1972. Its aim? Not to land on the surface, but to prove NASA's life support systems, navigation, communications, and safety systems work in deep space. A 10-day mission. The crew, consisting of Reed Wiseman, Victor Glover, Christina Koch, and Jeremy Hansen, were originally scheduled to launch in early 2026. However, the mission has faced a series of technical delays since then, and the launch window has slipped from early February to 6th of March to the 1st of April at the earliest. Why exactly? Well, let's take a look at the timeline. On the 17th of January 2026, the SLS, or Space Launch System rocket, and attached Orion spacecraft were moved to Launch Pad 39B in anticipation of an early February launch. This was a success, but that's sort of the end of things going right. Nearly 2 weeks later came Wet Dress Rehearsal 1, a full fueling test and countdown simulation. Whilst it wasn't a complete flop, teams detected a liquid hydrogen leak whilst fueling. Hydrogen is the smallest molecule in the universe, and at the temperatures required for flight, minus 252 degrees Celsius, it is particularly difficult to contain. So a leak wasn't completely unexpected, but it's not something you can fly with either, so it did require replacing seals and a ground support filter. Failure 1. Wet Dress Rehearsal 2, which concluded on the 19th of February, was much more successful. The team loaded 2.6 million litres of liquid hydrogen and oxygen into the rocket stages and completed 2 countdown tests. There were no leaks, and the rocket was signed off as good to go. Until it wasn't. Post-test, during a routine purge and repressurization procedure, engineers discovered that helium wasn't flowing correctly deep within the interim cryogenic propulsion stage, the upper stage of the SLS. Helium is vital for these rockets. It's used to maintain pressure in the fuel tanks and to purge the engine lines, so a leak puts the whole mission at risk. Without it, you'd have no propulsion. The culprit was eventually traced to a seal and check valve, but because it was located in a section of the rocket that is inaccessible while sitting on the launch pad, NASA was forced to roll the entire 98-meter tall stack back to the vehicle assembly building for repairs. These recurring leaks weren't just annoying. In many ways, they were a sign of a bigger problem. More tech isn't necessarily better. Not only is there a lot more to go wrong with Artemis than the initial Apollo missions, but we don't launch them very often either. In November 1967, Apollo 4 was the first flight of the Saturn V rocket. Less than 2 years later, the Apollo 11 crew was delivered to the moon by one. The last time the SLS went up was in 2022 as part of Artemis 1. That's nearly 4 years ago at the time of recording. NASA Administrator Jared Isaacman has noted that launching a rocket as complex as the SLS only once every 3 years leads to skill atrophy among the workforce. In other words, people aren't getting enough practice, which is leading to mistakes. To combat this, NASA has a new plan. Increase the frequency of launches to once every 10 months. This is meant to keep the hardware and the teams sharp, but it's still a long way off. Artemis 2 needs to get up in the air and then out of it first. Beyond the plumbing and what NASA seems to be politely hinting at as a rusty skill set, there is also a deeper, more sobering reality setting in. The sheer risk of what we are trying to do. It has been over 50 years since a manned spacecraft left Earth's orbit for the moon, and recently NASA officials have been under fire for sidestepping questions regarding likelihood of mission failure, or to put it bluntly, death. In the Apollo era, we were taking steps into the unknown, and the end results were seen as justifying the extremely high risks. Now we know it can be done safely, the tolerance for such potential disaster and the loss of life is far less. And the truth is, flying to the moon for the first time in 54 years is an inherently dangerous gamble. We're using new software, new contractors, and a rocket that has only flown once before. Even though Artemis 1 was considered a near-perfect test flight, it revealed anomalies that could be catastrophic with a crew on board. NASA must balance the pressure to meet a political schedule with the reality that any single Type A mishap could end the program entirely. After 2 aborted launch attempts, the uncrewed Artemis 1 mission blasted off on the 16th of November 2022 from Cape Canaveral in Florida. This was the first time NASA's SLS rocket and the Orion module left the bounds of Earth. The mission lasted for 25 days and 10 hours before Orion splashed back down on Earth, and as I mentioned, it was a great success, proving that we can indeed make it back to the moon with a craft capable of transporting humans. The European service module went one step further, generating so much extra power within its solar arrays that it had time to use them as a selfie stick. This image is of Orion looking back at Earth. It was only in the aftermath of the mission that the anomalies appeared. One of the most critical issues was Orion's heat shield, particularly how it behaved hurtling back to Earth at 40,000 kilometers an hour. Post-flight inspections found that the ablative material that covers the shield, called AvCoat, had chipped and eroded away in more than 100 places in ways that were never seen during the Apollo era, despite the same material being used. This shield stands between fragile human astronauts and the extreme temperatures that friction causes upon re-entry, and chunks of it just broke off. NASA's investigation into the damage found that gases generated during the intense heating of re-entry were getting trapped inside the AvCoat material. Usually these gases vent out through the charred layer, but because this specific material lacked enough permeability, internal pressure built up until the shield literally cracked. With enough damage, this could lead to the entire capsule burning up, which is not a risk you can take with people inside. On the back of this discovery, NASA has made a rather controversial decision. Rather than redesigning the shield, they are instead changing the way astronauts return to Earth. On Artemis 1, Orion used a skip entry maneuver, where the capsule dips into the atmosphere, skips back out like a stone being skimmed on a lake, and then re-enters, the whole process reducing the speed of the capsule. While it also reduces the G-force on the crew, it actually makes the heat shield problem worse by allowing gases to build up during that skip phase. For Artemis 2, NASA will skip the skip, performing a steeper, more direct re-entry that is harder on the astronaut's body, but safer for the shield, and hopefully in the long run, the astronauts themselves. Short-term pain, long-term gain. They'll be alive. It's a fairly large change to the mission, but is in no way the biggest to hit the news lately. The pathway through the Artemis mission has been somewhat set since the word go. Artemis 1, prove our rocket and spacecraft can make it to the moon. Artemis 2, add in the astronauts to test and verify all the other systems needed as they do a lunar flyby. Artemis 3, land on the moon. For 9 years, Artemis 3 was marketed as the grand return, the moment human boots would finally touch the lunar soil again. But as of February 2026, that plan has been scrapped. Artemis 3 will no longer land on the moon. Instead, it has been redefined as a 30-day all-up systems test in low Earth orbit. I'll explain what this is in a minute, but the reason for this change is safety and complexity. An independent safety panel warned that the previous plan carried a compounded level of technical risk. To land on the moon, the Orion capsule will first have to dock with SpaceX's Starship Human Landing System, the vehicle that will transfer them to the surface in a very specific lunar orbit. But Starship is a massive vehicle that requires more than a dozen tanker flights just to refuel before it can leave for the moon. NASA realized that attempting a lunar landing with so many firsts all in one go, the first crew docking, the first cryogenic fuel transfer, and the first of new spacesuits, was perhaps not the best way to do it. Instead, Artemis 3 is now doing what Apollo 9 did in 1969, staying near Earth to test the lunar module before anyone is allowed to take it to the moon. In 2027, Artemis 3 will see Orion rendezvous and dock with either SpaceX's Starship or Blue Origin's Blue Moon lander right here in Earth's backyard. This allows them to test life support, communications and docking procedures without the life or death stakes of being nearly 390,000 kilometers away. This shake-up in mission planning also involves a radical change to the rocket itself. For years, the plan was to upgrade the Space Launch System to a more powerful version called Block 1B, which features a massive new upper stage called the Exploration Upper Stage, or EUS. But the EUS has been long criticized due to delays and cost overruns. Under the new leadership of Jared Isaacman, NASA has cancelled the EUS entirely, along with the Block 1B and Block 2 upgrades. In a major move to standardize the fleet, NASA has taken a different route, officially selecting United Launch Alliance's Centaur 5 as the new upper stage for the SLS, starting with Artemis 4. The Centaur 5 is a dual-engine stage already in use on ULA's Vulcan rocket, and it represents a near drop-in replacement that allows NASA to abandon the costly development of the EUS. While it holds about twice as much fuel as the existing ICPS, it is compatible with the current Mobile Launcher 1, the ground structure that is used to assemble, process and launch NASA's SLS rocket and Orion spacecraft, meaning they don't have to wait for the construction of more massive launch infrastructure. It's by sticking to this standardized SLS that they hope to escape the cycle of 3-year gaps between launches and move towards the mission every 10 months that I mentioned before. So, to the big question I know you're all asking. If Artemis 3 is now a dress rehearsal in Earth orbit, when will we actually land on the moon? Well, I'm afraid it's quite a way off. The new target for Artemis 4 is in early 2028. What I will say though is that the scientific payoff at the lunar South Pole is where the real depth of this mission lies, and it'll be worth the wait. Unlike the Apollo landing sites near the equator, Artemis 4 is set to land at the South Pole of the Moon, a world of eternal shadows and brutal extremes. Because the Moon's axis is nearly vertical, tilted only 1.5 degrees, the Sun stays low on the horizon, casting shadows that haven't moved in billions of years. These are the permanently shadowed regions, or PSRs. Inside these craters, temperatures can be as low as nearly minus 240 degrees Celsius, colder than the surface of Pluto. This is where the gold rush of the 21st century begins, the search for water ice. We now know that these dark craters act as cold traps, preserving ice that likely arrived via comets and asteroids eons ago. And this isn't just a scientific curiosity, it's a strategic resource. If we can harvest water ice from the moon, we can split it into oxygen for breathing and hydrogen for rocket fuel. The moon becomes a deep space gas station, the essential first step for any future mission to Mars. Artemis 4 will carry a suite of advanced instruments to investigate this frontier. One of the most important is DUSTER, the Dust and Plasma Environment Surveyor. Lunar dust is one of the greatest threats to human exploration. It's not like Earth dust. Instead, it's made of tiny, jagged shards of volcanic glass that are electrostatically charged by the solar wind. It sticks to everything, grinds away at seals, and is toxic if inhaled. DUSTER, mounted on a small autonomous rover called MAP, will study how this dust behaves when a lander touches down or when astronauts walk through it. Alongside DUSTER will be the South Pole Seismic Station, or SPSS. This seismometer will listen to the heartbeat of the moon, measuring moonquakes and the frequency of meteorite impacts. The astronauts will even use a thumper, a device that creates controlled seismic waves to map the structure of the ground beneath their feet, looking for the telltale signatures of buried ice deposits. One specific area of interest is Shackleton Crater, which is 21 kilometers wide and 4 kilometers deep, a place where the walls are so steep they exceed a 30-degree slope, creating a perfect trap for ancient volatiles. To operate in this environment, the astronauts need more than just a rocket. They need a new skin. The next generation of explorers will wear the Axiom Extravehicular Mobility Unit, or AXIMU. These suits, developed in partnership with Axiom Space and even the fashion house Prada, are a massive leap over the Apollo A7L suits. The old Apollo suits were notoriously stiff. Astronauts often had to bunny hop because they couldn't easily bend their knees or waist. The AXEMU uses a hybrid design of hard-shell parts and advanced fabric joints that provide a range of motion never seen before in a pressurized garment. The suit is essentially a self-contained spacecraft. It features a life support system that can withstand the extreme cold of the PSRs for at least 2 hours. It includes 4G LTE communications developed with Nokia, and a high-tech visor system developed with Oakley. Most importantly, it is built with seals and materials specifically designed to keep the abrasive lunar dust out of the joints and the airlock. Artemis 3 will be the first time these suits are tested in the actual vacuum of space before they are relied upon for the landing in 2028. But as well as all this cool science, there's something else going on in this race to get back to the moon. Geopolitics. Despite increased costs and a desire to prove that they can execute on their promise to go back to the moon, NASA's urgency for another lunar landing has another big driver: what they are calling credible competition from China. Beijing has been methodically checking off milestones, including returning samples from the moon's far side and announcing their own plans for a crewed landing by 2030. US officials are concerned about a space sector capture, the idea that China could establish a presence at the resource-rich South Pole and effectively claim it as their own territory. If that happens, then NASA's plans for future Mars missions and beyond could crumble into moon dust. It's turned Artemis from a scientific mission into a strategic necessity to win the race. Only time can tell if they will come out on top. The journey to the moon has always been a story of trial and error. In 1969, we reached the lunar surface because we were willing to take enormous risks in a race against time and the Russians. Today, the stakes are different. We aren't racing to plant a flag, we're racing to build an economy. The transition to a standardized SLS with the Centaur 5 stage, the low Earth orbit test of Artemis 3, and the deep science of Artemis 4 represent a move towards a sustainable, repeatable presence. Simply putting a person back on the moon won't be enough to win the geopolitical war. The moon's south pole remains the most significant scientific target in our solar system, a place where the history of our planet is frozen in shadow, where the fuel for our future is waiting to be found. The road to 2028 may be longer and more complex than we anticipated, but the foundation we are building now is meant to last not for a decade, but for a century. On the 12th of March, NASA gave the official go for crew to prepare for a 1st of April launch on Artemis 2. With the astronauts in quarantine and the rocket back on the launch pad, I for one really hope it takes off. After all, regardless of the technical failures, budget overruns and changing geopolitical landscape that have forced a radical rethink of how we get back to the moon, it would be great to watch another moon landing, especially for those of us who weren't around to see it the first time.
We did it. We have returned to the moon. After 54 years, setting foot on our moon had become a distant memory. All that was left to remind us we ever visited was a collection of grainy film reels, some iconic photographs, and a few hundred kilograms of lunar rock. But on the 1st of April 2026, that changed. We went back. Not boots on the ground yet, but in the vicinity at least. And Artemis 2 wasn't just a repeat of Apollo, it was a total reimagining of how we explore. From high-definition laser streams to real-time observations of meteors slamming into the lunar crust, this 10-day voyage has revealed our closest celestial neighbor in ways we've never seen before. But every step into the unknown comes with risk. Between critical engine leaks and malfunctioning life support, not all was as smooth as it seemed. I'm Alex McColgan and you're watching Astrum. Join me today as we leave Earth and head back to the moon. We'll look at the triumphs, the discoveries, and the narrow escapes of the Artemis 2 mission, paving the way
for our return to the moon. On the 1st of April 2026, at 6:35 PM EDT, the countdown reached 0, and humanity was on its way back to the moon for the first time in more than 50 years. The SLS rocket produced a staggering 39.1 million newtons of thrust as it set off from the Launch Complex 39B at the Kennedy Space Center, pushing the Integrity capsule through the sound barrier within seconds. Inside, Commander Reed Wiseman, pilot Victor Glover, and mission specialist Christina Koch and Jeremy Hansen were pressed into their seats by forces reaching nearly 4 Gs. Artemis II was finally on its way. In less than 9 minutes, the crew were already in orbit around Earth. But they weren't heading straight for the moon. Instead, they spent the first 24 hours in this high elliptical Earth orbit on a trip designated as a shakedown cruise. This was a critical testing phase, making sure every system was working as it should before pushing on into deeper space. After all, this was the first time 4 humans were living and breathing inside the Orion architecture. They needed to make sure it was performing properly before leaving the relative safety of Earth orbit. The crew performed checks on the environmental control and life support system, monitoring the scrubbers designed to pull carbon dioxide and water vapor out of the cabin air. It sounds like a routine check, but in microgravity, carbon dioxide is a silent killer. Without the convection we have on Earth, carbon dioxide doesn't disperse. It pools in stagnant pockets right in front of your face. If the ventilation fails, you could effectively suffocate while wide awake. A sobering thought when you're thousands of kilometers away from any potential rescue. A little over 3 hours into the mission, the crew also conducted proximity operations, where they used the jettisoned interim cryogenic propulsion stage as a reference target, maneuvering Orion within close range to simulate the docking procedures required for the Artemis 3 and 4 missions. Over the course of 70 minutes, they repeatedly performed controlled approach and retreat maneuvers, collecting precise navigation data. Out here in space, the crew had no GPS to rely on, only the physics of the engine and the steadiness of pilot Victor Glover's hand. However, even this early phase wasn't without its hiccups. Not long after launch, the crew realized that a valve in their water dispenser had closed itself due to the immense G-forces. A faulty valve meant the crew couldn't count on getting water out of the main tanks in the usual way, so they manually extracted 7 liters of it into backup bags using syringes and straws, just to make sure they would have enough to drink for the rest of the mission. Even more concerning was a leak discovered in the helium manifolds, a part of the rocket used to pressurize the propulsion system. The leak rate was noted to be an order of magnitude higher than anything seen during ground testing, but thankfully the mission controllers determined it was still within acceptable safety limits. The next stage of the mission began on the 2nd of April, when the Orion spacecraft service module engine ignited for the trans-lunar injection burn, a 6-minute firing that accelerated Orion to nearly 40,000 kilometers per hour, enough to escape Earth's gravity. As they left the planet behind, Orion transitioned to a new era of deep space communications. Alongside the traditional S-band radio of the Deep Space Network, which has been the backbone of spaceflight since Apollo, Artemis II debuted a game-changer, the O20, or Orion Artemis II Optical Communications Terminal. The system uses near-infrared laser light at a wavelength of 1,550 nanometers. Unlike radio waves, which spread out significantly over long distances, these lasers remain tightly focused, allowing for a 30-fold increase in data density. At its peak, O20 downloaded data at 260 megabytes per second, enough to stream high-definition 4K video from around the moon, all the way back to ground stations in New Mexico and California. By day 4, the O20 terminal had transmitted more than 100 gigabytes of data. Among these files was the already infamous Hello World photo, captured by Commander Wiseman through Integrity's window it shows Earth as a dark sphere, lit only by a thin, razor-sharp rim of light as it eclipses the sun. To capture the faint details of the Earth's night side, Wiseman had to push his Nikon D5 camera to a staggering ISO of 51,200 with a quarter-second shutter speed. The camera is so sensitive that it also saw something the human eye could only dream of: the ethereal green glow of the auroras shimmering at the poles, and the planet Venus as a bright silver glint in the corner of the frame. You can even see our atmosphere, with air glow from excited sodium atoms lighting up its very edge, and the zodiacal light from space dust reflecting sunlight, a phenomenon usually seen only in the darkest skies on Earth. This, to my mind, is one of the most beautiful images ever captured by a human hand, and it was the first of many as the mission progressed. But while the view from the window of Integrity was spectacular, it was what the crew couldn't see that posed a great threat. As Integrity left the protective magnetic umbrella of Earth, the crew faced the invisible hazard of deep space: radiation. Radiation beyond Earth's orbit is up to 100 times more powerful than what we experience on the ground, consisting of galactic cosmic rays and solar particle events. To track this, Orion was equipped with 6 hybrid electronic radiation assessors and 4 specialized detectors called M42EXTs, which featured 6 times the resolution of previous models to distinguish between hazardous heavy ions and protons. But why did they want to track it with such precision? Well, radiation can have a huge impact on the human body, and we don't fully understand how, particularly in space. Artemis II gave NASA the opportunity to look at the biological impacts of going to the moon. Riding along in the cabin were tissue chips, part of the AVATAR investigation, which stands for a Virtual Astronaut Tissue Analog Response. These chips, roughly the size of a USB drive, contained living human cells grown to mimic the structures of the heart, lungs, and bone marrow. By flying these biological proxies, which were derived from the astronauts' own stem cells, scientists could observe cellular damage and immune function changes in real time. Later in the mission, the crew was supposed to practice a sheltering maneuver, moving equipment and water bags to create a thick barrier in the stowage lockers. While this demo was eventually shortened to make room for other tests, in the event of a severe solar storm, this safe room would be their only protection against acute radiation sickness, which can cause symptoms ranging from nausea and skin burning to long-term cancer risks. It's a haunting thought. 4 humans huddled behind water bags in a dark locker, millions of kilometers from help. It begs the question, is the moon really worth such a terrifying gamble? Well, on day 6, as the darkness gave way to a looming, cratered horizon, the crew got their answer. When the Artemis II astronauts peered out of the window on the 6th of April, Earth was no longer the largest world in view. Instead, our tiny moon dominated the vista. Integrity was entering the lunar sphere of influence. But this came with another set of risks. As they swung around the far side of the moon, all communication went silent. For 40 long minutes, the crew was completely cut off from Earth as the moon itself blocked our radio signals. The 4 astronauts were truly alone. Then, a crackle of static broke the silence. As Integrity cleared the lunar limb, the O20 laser system locked back onto Earth, and the crew's voices returned to mission control.
Integrity, comp check.
They had successfully emerged from the shadow of the moon, only to find themselves further from Earth than any human has ever been, 406,771 kilometers from home, shattering the 56-year-old record set by the crew of Apollo 13. This moment birthed the term Moon Joy, a profound sense of human connection and awe as the crew relayed descriptions with a human voice, something no robotic cameras could ever replicate. Christina Koch described the lunar landscape becoming real to her, noting how the moon looked like a sponge of light, turning from an electric grey to olive brown once the brightness of Earth entered her field of view. The crew utilized their extensive geology training to describe features like the Oriental Basin. This nearly 1,000 kilometer wide impact crater sits on the boundary between the near and far sides of the moon. Wiseman described it as an annular ring that looked like a pair of lips or a kiss on the surface. The crew also noted mysterious squiggles, winding surface features whose origins remain a topic of intense scientific debate. But Artemis was never just about seeing the moon. For the astronauts at least, it was far more personal than that. Amidst the high-stakes science, the mission paused for a moment of profound personal reflection. While passing over the boundary of the near and far sides, mission specialist Jeremy Hansen requested the naming of two previously unnamed craters. The first was named Integrity, a fitting tribute to the vessel that carried them there. But it was the second name that carried the most weight, Carol, in honor of Carol Taylor Wiseman, the late wife of Commander Reed Wiseman. When Carol was diagnosed with cancer in 2015, Reed had considered walking away from NASA entirely to be by her side, but she wouldn't let him. Instead, she pushed him to stay in the Artemis program. While Carol never got to see Commander Wiseman reach the moon, her name is now a permanent part of it. Inside the cabin, the crew embraced in a group hug that was felt by millions watching on Earth. Carol Crater is a small, bright spot roughly 5.6 kilometers across, located on the western limb of the moon. Because of its position, it is occasionally visible from Earth with a powerful telescope, allowing Wiseman's daughters, Katie and Ellie, to look up and see their mother's legacy on its surface. What a wonderful tribute. And there was another poignant moment in this phase of the mission. This is Earthset, a haunting image taken by Commander Wiseman that echoes the iconic Earthrise image taken by Apollo 8 astronaut Bill Anders some 58 years ago, as he too flew around the moon. It truly makes you appreciate how special Earth and our place in the universe is. And there are still more spectacular images on the way. As Orion moved into the moon's shadow, the crew experienced a total solar eclipse from a vantage point never before seen by human eyes. For nearly an hour, the moon, appearing 5 times larger than the sun, blocked out the solar disk. The astronauts used special eclipse glasses to study the sun's corona, the sun's outermost atmospheric layer, which appeared as a glowing halo around the dark lunar disk. In this image from the onboard cameras, you'll notice a faint, ghostly glow clinging to the left edge of the moon. This is Earthshine, sunlight reflecting off our own planet to light up the lunar limb. Even more impressively, with the sun's glare hidden behind the moon, the crew witnessed a rare planetary parade. Saturn, Mars, Mercury, and Venus all appeared in images of the eclipse as bright point sources in the dark background. This darkness also allowed for one of the moon's most startling scientific discoveries. While observing the night side of the moon, Wiseman and Hansen spotted quick flashes of light. These were impact flashes, millisecond-long bursts of bluish-white light caused by micrometeorites slamming into the lunar surface at tens of kilometers per second and vaporizing on impact. The crew logged at least 6 distinct impacts. In Houston's Science Evaluation Room, geologists were jumping up and down with delight. Witnessing these events in real time is exceptionally rare and proves that the moon is under a much more constant bombardment than previous models suggested. The data is critical for the safety of future outposts, and it suggests that the daily flux of meteors must be monitored more closely before establishing permanent bases. It turns out, micrometeorite impacts on the moon could be a much bigger hazard than we ever thought. But it was also a test of human patience. The cabin is roughly the size of a small camper van, and for 10 days it was home to 4 people. That's not a lot of space, especially if you have toilet troubles. It might sound silly, but one of the most significant challenges the Artemis II crew suffered was the toilet. The spacecraft's wastewater venting system malfunctioned several times, causing the storage tanks to fill prematurely and rendering the toilet unusable for long periods of time. This forced the crew to resort to backup urine collection bags, a messy, and I would imagine mildly disgusting, reality of deep space travel. Mission specialist Christina Koch, drawing on her engineering background, became a space plumber, performing in-flight plumbing repairs to keep the systems running. There were lighter moments too, of course. On Easter Sunday, the crew held a zero-G egg hunt, searching for packets of dehydrated scrambled eggs hidden around the spacecraft. They were also joined by Rise, a plush mascot designed by 8-year-old Lucas Yee from Mountain View, California. Rise served as the mission's zero-gravity indicator, a small, hat-wearing plushie that became a viral sensation, symbolizing the mission's moonjoy and carrying more than 5.6 million names of people from Earth on an SD card inside his pocket. It was a beautiful connection to home, but home was still more than 250,000 kilometers away, and as the mission turned back towards Earth, the focus of ground teams shifted to a growing concern in the service module's propulsion system. The helium leak detected early in the flight had remained an issue. Helium is used to pressurize the propellant tanks, pushing the fuel into the thrusters, and any loss of pressure could compromise the spacecraft's ability to maneuver. As I mentioned before, NASA's Associate Administrator Amit Kshatriya confirmed that the leak rate in flight was an order of magnitude higher than what was observed on the ground. While it didn't threaten the safety of Artemis II, the anomaly has forced a significant change in the program's roadmap. NASA has indicated that the valve system will likely require an extensive redesign before it is certified for the long-duration orbital maneuvers of Artemis IV in 2028. This is the very essence of why Artemis II exists. It is a detailed test objective. This is where we push the limits of the hardware in a controlled environment, if you can ever call space that, so that flaws can be fixed before the stakes get even higher on the lunar surface. But space hazards weren't the only thing troubling the astronauts. One part of the mission people were particularly concerned about was getting home, and specifically re-entry into the atmosphere. Getting to the moon is one thing, but getting back is arguably more dangerous, and that's been the case since the times of Apollo 11. Take a look at my videos covering this on Astrum Extra if you want to understand exactly why. And even after nearly 60 years, the method hasn't really changed. For the Artemis II crew, the return to Earth was a 4-day journey, with Integrity reaching a peak velocity of nearly 40,000 kilometers per hour. This is about 32 times the speed of sound. To protect the heat shield, Orion performed a skip re-entry. You might remember that from my last video about the mission. The spacecraft hit the upper atmosphere at a precise angle, briefly skipped back up into the void to lose kinetic energy and heat, and then made its final plunge. This maneuver kept the temperatures on the heat shield around 2,760 degrees Celsius, within the safety margins for the modified AVCoat material. As the capsule slammed into the atmosphere, the friction was so intense that it tore the air molecules apart, turning the surrounding air into superheated plasma. This sheath of ionized plasma acted as a signal barrier, blocking all radio communication with the crew. For 6 agonizing minutes, they completely cut off from Houston once again, and the world held its breath as a single pinprick of light was tracked by infrared cameras on recovery aircrafts. Through the static, Reed Wiseman's voice finally punched through.
Houston, Integrity, we have you loud and clear.
The relief across mission control was instant. Moments later, 3 massive parachutes, each more than 30 meters in diameter, opened against the California sky, slowing the capsule to a gentle 27 kilometers per hour splashdown. The mission ended at 5:07 p.m. Pacific Daylight Time on the 10th of April with a bullseye splashdown in the Pacific Ocean west of Baja, California. The recovery ship, USS John P. Murtha, was positioned within a mile of the landing site. Navy divers approached in inflatable boats, checking for toxic propellant leaks before installing the front porch, a large inflatable raft that wrapped around the floating capsule. The 4 astronauts exited the side hatch onto the porch, where they were given initial medical assessments before being hoisted into the MH-60S Seahawk helicopters and flown to the ship's medical bay. Commander Reed Wiseman was last to leave the capsule, but he didn't leave alone. He carried Rise with him, stuffing the mascot into a dry bag on his pressure suit to ensure no man or plush would be left behind. Within 24 hours, the crew was back at the Johnson Space Center in Houston, reuniting with their families and marking the end of a 1.1 million kilometer journey. Since then, the science work hasn't stopped. The astronauts' experience of microgravity is being used to work on treatments for vertigo, and the Orion capsule was also successfully rescued from beneath the waves, ready for further examination back at base. And the next step, of course, is the Artemis 3 mission, which, whilst initially was set to be a lunar landing mission, has now been changed to a low Earth orbit test of the docking procedures with potential landing craft. At the moment, we don't know whether this will be the SpaceX or Blue Origin's lander, but we do know it won't happen until late 2027 at the earliest. And unfortunately, that's not the only setback. As we set our sights to Artemis 4 and NASA astronauts touching down on the moon once again, we are already seeing issues with the astronauts' spacesuits. A report of NASA's Office of Inspector General, an independent federal watchdog, has said that development is behind and risks not being ready in time. The new suits are needed because NASA's current versions used for spacewalks on the International Space Station were designed more than 50 years ago and haven't been changed at all in more than 20. They simply aren't made for the harsh environments of the moon. In 2022, NASA commissioned 2 companies, Axiom Space and Collins Aerospace, to come up with a new option, but in 2024, Collins dropped out as they couldn't do it in the time required. Whilst Axiom says that they will have demos ready in 2027, the clock is well and truly ticking for a potential 2028 Artemis 4 launch. The voyage of integrity has come to an end, but the era of Artemis is only just beginning. We have proven that our rockets can reach the moon, that our lasers can stream the wonders of the cosmos in 4K, and that the human spirit remains as curious as it was in 1969. The anomalies we faced, the leaks and the toilet issues, are not signs of failure, but the very reason we fly these test missions. They are the lessons we learn now with Orion, so that the permanent bases of the future can be safe. As the crew reunites with families, they leave behind a moon that is no longer a distant ghost. It's a world where a crater named Carroll now shines as a permanent monument to human memory. Artemis 3 is still a way away, but I think it's fair to say we are on our way back to the moon, and this time we're going to stay. I can't wait for the moment we get to see human boots touch down on the surface once more.
India's Chandrayaan-3 moon mission has already proven historic. It put India in the history books for being the 4th nation to ever successfully land a spacecraft on the moon, and the very first to ever land at its south pole. The lander Vikram and the rover Pragyan already made discoveries that could profoundly impact our understanding of the moon's chemical composition and geological history, and has given the world vital data that will aid future return missions to our lunar neighbour. And yet, for all the praise, which is well deserved, it's what Chandrayaan-3 did not discover, but should have, that I find the most intriguing. Have you noticed it too? India's NASA equivalent, ISRO, the Indian Space Research Organisation, made press releases before the launch, and there was always one thing they claimed they were primarily there to find. One reason the South Pole was picked out over all other locations. One mystery about the moon that is deepening the more we investigate, and yet needs to be solved before we can expect to start setting up permanent bases up there. Simply put, where is all the water? I'm Alex McColgan, and you're watching Astrum. And today we'll take a look at Chandrayaan-3, explore its successes, and attempt to use its discoveries to answer that one important question. It was India's Chandrayaan-1 mission that helped provide some of the clearest proof that the moon's polar craters might hold water ice. Water on the moon had been hypothesized since the 1960s, and in 1971, Apollo 14 found some traces of water vapor at the lunar surface. But water ice itself proved difficult to pin down. Scientists thought that if water ice was anywhere, it would be in the craters at the north and the south lunar poles. These craters were aligned such that they never received direct sunlight, and thus were very cold, some of the coldest places in our entire solar system. The perfect forming ground for ice. Sadly, images of these crater cold traps were too low resolution or simply too dark for us to know for sure, and while there were numerous detections of hydrogen on the moon's surface, it was unclear whether this took the form of actual water ice or not. However, in 2009, signs of hydration began to emerge. Chandrayaan-1, carrying a NASA Moon Mineralogy Mapper, found the first definitive spectrographic signatures of water ice in dozens of craters congregated around the moon's poles. This water map was later confirmed by Chandrayaan-2, leaving scientists increasingly confident that there was potentially 600 million metric tons of water ice to be found in the moon's darkened craters. Water on the moon is a big deal. More and more nations have goals of setting up bases on the moon, and being able to source your water from the moon's surface saves you from having to spend huge amounts of resources getting it up there. Water is vital for human life, but also could be broken down for hydrogen and oxygen, useful ingredients for rocket fuel, or a breathable atmosphere in your moon base. So it should come as no surprise that when Chandrayaan-3 began to make its way towards the moon, one of the things the media reported it was hoping to find was water ice. Chandrayaan-3 was launched on the 14th of July 2023. It was made up of a lander module called Vikram, a small rover called Pragyan, and an orbiter module that carried the other two components across the Gulf of Space. On the 23rd of August, Vikram, with the little Pragyan tucked inside, touched down on the moon's surface at the beginning of a lunar day. But time was not on their side. Chandrayaan-3 was a surprisingly cost-effective mission. While NASA's Artemis mission launches will each cost on average $4.1 billion, the entire Chandrayaan-3 mission only came to 6.15 billion rupees, or about $75 million, ironically less than what many modern blockbuster space films take to produce. Perhaps Hollywood should consider filming their next moon film on site. However, with this lower budget came technological limitations. When the lunar night fell, Vikram and Pragyan would be subjected to temperatures of minus 120 degrees Celsius, temperatures they were not designed to survive. A lunar day lasts 14 Earth days. The Chandrayaan-3 mission would need to complete its major objectives in that time, as their odds of surviving to the day after that were slim. And so Vikram lowered its ramp, and Pragyan, the rover, powered up and headed out down onto the moon's surface. Pragyan is a 27 kilogram, six-wheeled rover that came equipped with an alpha particle X-ray spectrometer for analyzing the chemical composition of the moon by firing radiation at it and seeing what wavelengths bounce back, and a laser-induced breakdown spectroscopy instrument that does a similar thing, but this time by firing a laser at the target of interest and analyzing the light wavelengths that are released by the resulting plasma. These two tools together would be enough for Pragyan to attempt to find water or any other interesting substances, confirming their composition for scientists once and for all. And so it set to work deploying both instruments on the ground next to it. Within days, the results started to come in. Aluminium, calcium, iron, chromium, and titanium were all found on the moon's surface, along with other interesting elements like oxygen. Indian scientists were most excited at the first ever in situ measurement of sulfur at the moon's pole. Sulfur is an exciting element to find, as it helps us understand the evolution of the moon over time, and indicates there used to be volcanic activity in the region. But in spite of all these discoveries, there was one element that was not showing up in the analysis. The all-important hydrogen was notably absent. Pragyan set off to explore further afield. Guiding the rover was all done manually by scientists back on Earth, looking through Pragyan's onboard navigation camera. This had to be carefully done, as the signal delay between Earth and the Moon meant that orders for the rover to halt lagged by a little under 3 seconds, time that might make all the difference if the little 6-wheeled rover was to avoid overturning. And indeed, this nearly happened. Early on in Pragyan's journey, the rover had to speedily stop to avoid falling into a large 4-meter crater scientists hadn't initially realized was there. I say speedily. Pragyan's move speed was 1 centimeter per second, hardly the fastest of sprinters. Over the course of its 2-week life, Pragyan traveled no more than 100 meters from Vikram. Fortunately, the crater was detected in time, and scientists were able to turn around and choose another route. However, when you look at Pragyan's route, you notice that there was a second moment where Pragyan did not travel down into a crater it came across, instead electing to go around. No photos of this second crater are currently available, so we are left to conclude that no ice was spotted there. Vikram itself did not remain idle during this time. It performed temperature readings of the Moon's surface, digging 10 centimeters deep to measure the Moon's warmth at different depths. It measured the plasma content of the atmosphere. Good news, there's not much up there, so radio communication to the Moon likely won't get much interference. It detected a possible moonquake, which, given the small 2-week window, was some excellent timing. At the very end of its journey, in a moment of final enthusiasm, the Vikram lander even successfully performed a 40 centimeter high hop, firing its boosters to lift itself off the ground, moving 30 to 40 centimeters along from its previous destination. Indian scientists had wanted to test how easy it would be for future landers to one day propel themselves back into orbit from the Moon, and this was a useful practice run. But none of this helped the Chandrayaan-3 mission to find water ice. By the 4th of September, time was up. Vikram and Pragyan were ordered to power down. ISRO scientists had hoped to wake them up again once the night ended, but this hope proved to be fruitless. The 2 lunar explorers had communicated with Earth for the last time. ISRO and the scientific community at large lauded their efforts and called the mission a success. And indeed it was, as India had gained first-hand data from the Moon that would be extremely helpful in building a picture of conditions at its poles, along with furthering our understanding of the Moon's history. However, it definitely raises a mystery. When I first heard that water ice had been detected on the Moon, I envisioned in my mind frozen ice lakes, or possibly tall penitentes. Perhaps a light frost, as vapor from the Moon's atmosphere ended up trapped in these darkened craters, freezing over the surface and building up over time. We know from orbiters like Chandrayaan-1 that water ice is indeed in these craters, and yet Chandrayaan-3 has joined other missions in failing to actually see this ice for themselves. I remember feeling similarly disappointed when I first saw the images captured by ShadowCam, a NASA camera carried on the South Korean Danuri moon orbiter. ShadowCam was so good at detecting light, it could see into the polar craters that hadn't seen direct sunlight in millions of years without issue. And yet, once again, there was nothing there. Nothing but arid dust. Given that Pragyan's analysis of the lunar regolith revealed no signs of water molecules, where is the water ice that Chandrayaan-1 detected? While this mystery is confusing, Chandrayaan-3 offers us a possible answer. Not through Pragyan's explorations, it's actually Vikram that possibly hinted at the solution. When Vikram used its chased temperature sensor, it was able to take 10 different readings of the Moon's temperature, starting at the surface and working its way down in 1 centimeter increments. What it found in the space above the Moon's surface was a temperature a little under 60 degrees Celsius. definitely too hot for you to walk around in if you happen to be on the moon and somehow didn't care about the lack of air. But curiously, as Chase measured deeper and deeper beneath the surface, this sweltering temperature dropped off fast. By 8 centimeters deep, the new temperature Vikram was detecting was minus 10 degrees Celsius. That's a big drop. From this we can see that lunar regolith is a really poor heat conductor. But that also indicates quite clearly that the best place we're likely to see ice is not resting on the moon's surface, but we actually need to look beneath it. There's much we don't understand about the moon and its water cycles. There's growing evidence that the moon contains quite a lot of water, and yet extracting it will take understanding where that water can be found, and how it moves throughout the long lunar days and nights. Is it affected by solar radiation? Is it trapped in hidden deposits? Although Chandrayaan-3 only lasted 2 weeks, which I'm sure is less time than ISRO scientists would have liked, it has offered us vital insights into the conditions on the moon. As far as water is concerned, at the very least, it has given future astronauts this one piece of advice. If you want to find a drink of water on the moon, you might want to start by bringing a shovel.
A massive thank you to our astronauts on Patreon. This video had no sponsors, but it was still made possible thanks to the hundreds of members we have there. Link is in the description to join our growing community. Patreon is where Astrum truly takes shape, a place for people who love space, who want to see these videos keep improving and reaching more curious minds. Every new member keeps the channel focused on what really matters, making the complexity of space available to everyone. If you enjoy what we do, come join the Astrum community today.